Welcome back. Today I'm going to be showing you how to measure drums and rotors to determine if they can be resurfaced or if they need to be replaced. This is going to be just the measurements, not the machine, nothing like that. And I'll use some tools that some of you may not have access to at home. So in my tool cart here, I have a drum and a rotor. Now I know what both of these are off of because it's written on them. So this one's upside down. But we've got a rotor off a 2016 Ford F-150. This is a front rotor. And then the drum is off of a 92 Dodge Dakota two-wheel drive. These were two of the better ones that I had to pick from as far as practice measuring. So I've got them here. I'm going to show you how to determine whether or not these are good to reuse. The rotor has a whole variety of different ways that I have readily available to measure this. One of the specialty ways that is made just for rotors is this rotor micrometer. And I zeroed this earlier because the tip is all messed up. But what this tip is supposed to be a fine point, so if you have a groove in the rotor, you can actually stick that into the groove and get a measurement of how much it's going to take to turn that rotor back clean. Now this micrometer is a little bit different than your standard micrometers. Most of these have 50 thousandths of an inch on the thimble, and each notch on here is going to be 50 instead of 25. They also have a larger range. So like this one starts at 0 and I believe goes up to 2 inch. Most of your rotors run somewhere between about a 1/2 inch and 1.5 inches. So in order to do that, our standard micrometers, which can also be used, generally run 1 inch and they start on the inch. So this happens to be a 1 to 2 inch micrometer. So it starts off at 1 inch and runs up to 2 inches. Another tool that I brought out here that really isn't that good for this, this is probably the worst tool that I brought out, is just a standard caliper. Now you can use a digital or an old school vernier caliper. Either one of them is about the same point. The problem I have with these is that they have straight jaws. So out here at the end of the rotor, where we get a rust buildup and junk there, and it doesn't wear the rotor down if you don't have rust, when we go to squeeze this over that, it doesn't work. It reads the widest part. So because these don't have a point, they're just not going to be as accurate or work as well. Something we've got that kind of solves that is this caliper that is made specifically for measuring rotors, and it's even got a point on it. So we've got a point to check grooves. We've got enough gap that we can get down into the center of the rotor and get a good measurement, and that's going to be our quick, easy digital readout way to do this. So with this particular rotor, and again, I couldn't find all the information I wanted to. I should have looked this up earlier when I had access to slightly better information than I do right now. But the only spec I could come up with on this rotor was the minimum thickness, which is 1.26 inch or 32 millimeters. So we'll measure this rotor out and see where we end up. And I'll actually use a couple of different measuring techniques. I'm not going to use all of them, but I'll use 2. And we'll measure this thing up. Now what we're going to want to look for is, like, this rotor is pretty badly damaged by hammers that removed it. On the back side, we also have hammer marks, and we have this wide ridge of rust. Now, being from Michigan and experiencing this stuff, most of the time when you've got, and this rust ridge here is actually lower than the surface that the brake pads ride on. Now, one of the things that you'll learn from experience, especially if you're in a really rusty area, is that this metal is so crappy now. These Chinese rotors are so poorly made and so low quality steel that the steel actually rusts underneath this contact pad. So when you put this on a lathe, you take this thin layer of what looks like good metal off, and then you are left with this rusty, nasty junk metal, and you have to replace it anyway. So the reality is that this rotor, just by looking at it and knowing how these things rust out, is not really worth my time to measure. That's why it got replaced. But for the sake of this demonstration, we're going to do it. So what I'll do is I'll stand this thing up. I'll take our disc brake micrometer. I'm going to find a nice spot right there. Snug it down. This one doesn't have a thimble on it, but we'll snug this thing down. I'm not sure if you're going to be able to read this. Kind of guessing this won't show up very well, but we've got 1.2 inch. Each notch is going to be 50, so we've got 1.2. So that first line would be 1.250. That next notch is going to be 1.300, and we've got 26 showing on the thimble here. So this is 1 inch, 326 thousandths. I'm going to zero this one out. Try to measure roughly the same spot. Okay, so 1.35. Close enough that I'm going to call them the same thing. Now, as we do this, as we're determining if this is going to be good to machine, we will check 3 different spots evenly offset throughout the rotor, and that will help us determine if it's got thickness variation or is going to have other issues being turned that we may not otherwise see. Now, you can measure the same way with the micrometer. You just have to have a full set. So this particular one would need a 1 to 2 micrometer. And we'll say that this one was at 1.33. And again, I'm writing upside down, so that's what we're going to go with. Okay, so right now we are at 1.335 inch, or 1 inch 335 thousandths. Our minimum thickness is 1 inch 260 thousandths. So as we look at this, we are currently sitting at 1 inch 335 thousandths. Our minimum thickness is 1 inch 260 thousandths. That means that we would have roughly 65 thousandths of an inch to work with. So that means that we could remove 65 thousandths of an inch from this rotor and still be acceptable to run it on the car, or at least reinstall it. Now generally, and I didn't see this spec on there, there will sometimes be a spec that's higher than the minimum thickness. That will be like minimum service spec. Now, do we necessarily want to machine a rotor right down to our minimum thickness and reinstall it? Not really. Do I think that this one would have some issues if we tried to machine it down to that? Yes, I do. So even though we have 65 thousandths worth of machinable rotor to work with, I don't really think that would be enough in this case. In most cases, if you don't have rust issues, you should be able to easily straighten out a rotor in 65 thousandths and get it back on the car and be able to reuse it. In this case, we're just not going to. I guess that's about it. I'm not going to go through each one of these. I gave you kind of the cliff notes on them. So there we are. Thanks for watching. I hope you learned something here today, and I'll see you next time. Don't forget to hit that like, subscribe, comment, all that good stuff. Still trying to grow this channel, so If you know somebody that may also be interested in this kind of stuff, go ahead and share it out. Thanks again.